Colby, math.com.
In this video, we're ordering rational numbers. Rational numbers are any number that can be written as a fraction. So whole numbers are rational numbers. Any decimal number can be written as a decimal fraction. Any repeating decimal can be written as a fraction. We're going to get into a lot about the definition of rational numbers this year in class. But here I have a long list of 6 decimal numbers written in standard form. And if I want to put them in descending order, that's greatest to least. Ascending order would be least to greatest. So descending, it's like if you're descending stairs, you're going down the stairs, right? So you're going from the highest stair to the lowest stair. So you go from the highest number to the lowest number. And ascending is just the opposite of that. When all the numbers are in standard form, it's very easy to order them because you can line up their place values, line up the decimals, line up the place values, and then just compare. So I have 1 and 34 hundredths, followed by 4 and 13 hundredths, followed by 0 wholes and 143 thousandths, followed by 0 and 134 thousandths, followed by 0 and 1,434 ten thousandths, followed by 3 and 14 hundredths. And so what I want to do is first create like terms. In these, this one, and the bottom one, I'm counting hundredths. In these two, I'm counting thousandths, and in this number, I'm counting 10 thousandths. By showing the zeros in the thousandths and 10 thousandths places, I can create like terms for all of these digits, and I can be counting 10 thousandths in all of them. Then if we want descending order, we're looking for the largest number first, and I can start with the greatest place value, which is the ones place in this case, and I can very easily see that this one is going to be the greatest. 4 and 13 hundredths, followed by the one that starts with 3 and 14 hundredths, and I'm writing them back in the form that they were originally given. So this one, 4 and 13 hundredths, I'm writing it the way it was given to me. I'm not including the extra zeros at the end. The only other one in our list that has a number, a positive number in the ones place is this first one, 1 and 34 hundredths. Now we can't compare these because all of the digits in the ones place are zeros, and then when I go to the next highest place value, the tenths, all of the digits in the tenths place are also zeros. So then we go to the not zeros, they're all ones. Then we go to the hundredths place, 2 of them have 4s, and 1 of them has a 3, so it's either this one or this one that's largest. I go to the thousandths place, they both have 3s in the thousandths. I go to the 10 thousandths, this one has 0 in the 10 thousandths, this one has 4, so this one is the next largest in the list. So 0 and 1,434 ten thousandths is next. I'm left with these last 2, and we can tell from the hundredths place that this is larger than this, so 0 and 143 thousandths, and finally 134 thousandths is the final one. And anytime you're making a list like this, we have quite a few numbers. I like to count my list. There are 1, 2, 3, 4, 5, 6 numbers in my ordered list, and there are 1, 2, 3, 4, 5, 6 numbers in my original list. So that's a good way to check your work. And this one's a little bit harder because they're not all in standard form, but on the next video, or in the section where we're converting rational numbers, we talk about converting fractions to decimals, decimals to fractions, percent to fraction. And so oftentimes, not always, but oftentimes in a situation like this, it's going to be easiest to convert these all to standard form, so convert them all to decimals. If there's a situation where most of them are percents and you can easily convert the ones that are not into percents or fractions or anything, you can do it any way you want as long as they're all in the same form. They're easier to compare. In this case, I think it's going to be pretty easy to convert these all to decimals. As I look at these numbers, they're all greater than one whole. 100% would be 1, so if I have 165%, that's more than 1. Obviously 1 and 69 thousandths is more than 1. 1 and 3/5 is 3/5 more than 1. And 37/20 is an improper fraction, so I know that's also greater than 1. Sometimes you can just compare to a benchmark number like 1, and you can start to make your ordered list that way. Sometimes you don't even need to use a number like 1, you can use a number 1/2. If you have a bunch of fractional numbers and you can tell some of them are less than half, some of them are more than half, then you're well on your way to ordering the numbers. But in this case, I'm going to convert them all to decimals. So 165%. Percent means out of 100 or divide by 100. So if I take 165, the decimal's not in sight, it's on the right. If I divide by 100, then I know this is equal to 1.65 in standard form. Hundredths, 165 hundredths. And this does say 165 hundredths. It's 165 ending in the hundredths place. So this is 1 and 65 hundredths. This is already in standard form. 1 and 3/5 is going to be easy to convert to standard form because it's easy to convert 3/5 into a decimal fraction. I can multiply by 1 in this form, 2/2, because 1/5 of a half is 1/10, and so we get 6/10. So 1 and 3/5 is equal to 1 and 6/10, and a decimal fraction can be written in decimal form, so 1 and 6 in the tenths place. So this is 1 and 6/10. 37/20 is equal to 20/20 and 17/20. So that's 1 and 17/20. 17/20 can be converted to a decimal fraction by multiplying it by 1 in this form, 5/5. Because a 20th of a fifth is 100th. 17 multiplied by 5 is 85. So we have 85 hundredths. So this is equal to 1 and 85 hundredths, which in standard form is 1 and 85 hundredths. Sometimes you're going to get, let me get a different color for this. Sometimes you're going to get you're going to want to convert to standard form, to decimal form, and you're going to have a fraction like this. And you can't turn sevenths into tenths, hundredths, thousandths. In this case, you just need to divide. Remember the vinculum, the fraction bar means divide. So this is 2 divided by 7. So you'd set up long division. 2 divided by 7. How many 7s are in 2? 0. So we just show the 0 in the tenths. We show the 0 in the tenths place and line up our decimal and our quotient. How many 7s in 20? 2. 2 multiplied by 7 is 14. Subtract, you get a difference of 6. Then I reveal the 0 in the hundredths place. Bring it down. How many 7s in 60? 8. 8 multiplied by 7 is 56. And you can continue working like that to get a decimal, and you may need to round it, but that's how you turn a fraction like this that's not easily converted into an equivalent decimal fraction. That's how you turn that into a standard form. Okay, if I'm lining these up using using the method we used in the last page, 1 and 65 hundredths, 1 and 69 thousandths, 1 and 6/10, 1 and 85 hundredths. And this time we're going least to greatest. And so I'm going to create like terms by showing the 0 in the thousandths place here, the 0 hundredths and the 0 thousandths here, and the 0 thousandths here. The least, I can't use the ones place, they're all ones. But in the tenths place, it's very clear to see that this is the least. since it's 0 and the others are 6 and 8. So 1.069, 1 in 69 thousandths is my least value. My next greatest value is 1.600, which was 1 and 3/5. So that's next, 1 and 3/5. These lists should be written back in the original form. So I'm turning 1.600 back into 1 and 3/5. And then next would be 1.65, 1 and 65 hundredths, which was our percent, 165%. And lastly, the 37/20ths. So there's our list from least to greatest. Okay, I hope that helped with that. There's lots of practice for you to do down below the video. Thanks for watching the video.